Hello, class. Sorry about yesterday. I did have a heavy migraine, which it really prohibited me from uploading any videos and assignments that was due anything yesterday. I'm feeling all better now. Thanks for your words on the Google Classroom. And let's get back to it. Okay. So it's already May 14th, May 15th, halfway through May. And I just want to go over a couple of things before I start the video for today. We'll still be talking about expected values and everything, but here is a important announcement that I need you guys to understand. June 2nd, which is about 3 weeks from now, it's going to be your math final. Okay, from June 1st to June 4th, that all will be your finals, like for your social studies, science, and ELA. I believe June 1st on Monday, that would be your ELA exam, and this is Tuesday. Now, after June 2nd until the last day of school, which is June 5th, those 3 days, June 3rd through June 5th, will be used as your makeup days. So anything that you have missed, any missing assignments, any outstanding, like those before I have to turn in the grades, I want to make sure that we use those last 3 days to really catch up with any missing assignments and work or retakes that if you guys want to do anything like that, that those 3 days will be used for that. Today is the 14th, and tomorrow's the 15th. We'll be still talking about the expected values. Okay, this is the last topic in which we're going to be talking about in terms of probability. Starting on next week, which would be May 17th until May 22nd, we will still be talking about probability and we'll be wrapping up probability. I'm not going to teach you anything like maybe extra, but because expected values is such a small topic, I don't really see it as being more than 17th and 18th or anything beyond that. Um, what we're gonna do pretty much after that, I still have to decide. I don't want to do trigonometric functions at all. I don't want that to be, the part of our exam because we don't really have to do that. But first, I think more importantly, we could make sure that everything from the beginning is okay. But starting from the 25th, which is Memorial Day, so we don't have school that day, 26, 27, 28, 29, those 4 days will be used for your review for your final exam the next Tuesday. So really just this week, it's still up in the air what we're going to do, but we're most likely going to be taking one more additional test. But the last week, but please consider that as a review. Anything that's covered in a math final, I'm going to make sure I give you enough homework questions on it and to make sure that you guys are going to be okay with the final. On Monday, which you will have ELA exam, so I don't want to give you any work. On June 1st, I'm going to post all the answers. Maybe I'll post answers a little bit in advance so you guys can study for it. Answers, videos, any questions you guys might have about the final, we can just go over that on June 1st. And that's pretty much the plan for the rest of this month and the rest of the school year. It is kind of disheartening to see that we're gonna have to say our goodbyes virtually and not really in person. But it's been really interesting year with all this remote learning, and hopefully everything goes well, and I hopefully get to see you guys again. Okay, so that is the plan. Unfortunately, I wrote this down on where I was supposed to be doing the work, but I'm going to be erasing this part. Still, this is going to be written on the Google Classroom anyways. For today, I want to go over a couple questions where you're dealing with the percentages and like a probability, and you need to find out what is your expected number of days that it's going to rain. Like, for example, number 8. A travel website reports that in a particular European city, the probability of on any day raining is 40%. Then, what is the expected number of rainy days in the city during the month of April? Okay, so what do we do? How many days are there in April? There are 30 days. Out of these 30 days, how many days can you expect? This is the question. Can you expect to see rain? If every 1 day gives me 0.4 day, I know this is not physically possible, Okay, yesterday we've been talking about how it's impossible for us to roll 3.5 on our dice, but that is what's expected. That's what we can expect out of. That's the outcome. So if every one day gives me a 0.4 day of rain, how many days can you expect when it's 30 days? It's pretty simple. You can set up a ratio where it's 1 is equal to 0.4 and 30 days is equal to x, or because this is multiplied by 30, you can just simply multiply that by 30 as well. So in this particular question, the answer here would be 12 days. Why? Because every day you can get 0.4. So 0.4 on one day, 0.4 the second day, 0.4 the third day, all the way down to 0.4 on the 30th day. So if you were to add them all up, you will get 12 days. Okay? Pause the video and then see if you can finish this question. So, according to the weather app, Talisha's smartphone, there is a 40% chance of rain for each of the 5 days of her vacation. How many rainy days should Talisha expect? 0.4 times 5. It's just the probability times the number of days. Yesterday we talked about how the expected value is equal to the probability times the value, or I believe it was x1 times p1 plus x2 times p2 plus all the way down to xn times pn. This, only one of them is what you're going to be doing, and that is essentially all your expected value outcome is going to be. So your final answer, 2 days. 2 days out of the 5 days that she's going to have vacations in, you can expect to have rain. Okay? Alright, so let's take a look at this table for the last part for this video today. The table shows data on sales of 1 month for each item on the restaurant menu. To estimate future profits, the owner evaluates the average profit from each meal. Part A says, based on the data, what is the average profit that the owner can expect to make from each meal? Okay, so what was the expected value, in which what we need to do? We need to multiply the value with the probability of the corresponding, and then we need to add the value times the probability of the second one correspondingly, and then you need to do it 2 more times because there are 4 items on the menu. So we take this value, 0.34, and we multiply it by the probability. We take the 41 cents value and we multiply it by the 7%. 64 cents, 0.45, 0.73, and 0.36. We simply just take each of these probability with the values. Okay? And then once we multiply them, let's see. I'm going to take 0.34 times 0.12 and get 0.0408. 0.41 times 0.07, I get 0.0287. 0.64 times 0.45, I get 0.288. Lastly, 0.73 times 0.36, I get 0.2628. So what I'm going to add is all of these values, and then I end up getting this, 0.6203. What does that mean? It means that you can expect to gain 62 cents per meal that you sell. Doesn't sound like a lot, but this is just a projection. Now, what is the expected profit for the next 200 meals ordered? For this type of question, you need to say, okay, for every 1 meal, it gives me about 62 cents, 0.6203. How much can I expect for 200 meals? It's the exact same questions as we have done for this one, where we set up a ratio and we solve. But in most cases, what you're going to think is, okay, if 1 meal gives me 0.6203, to go to 200, I just need to multiply that by 200. So, because it's a restaurant, you're not just going to make 1 meal per day. You're going to make hundreds and hundreds of meals for customers that comes in on a daily basis. So this answer would be $124.06. So simply have to multiply with the probability, or with the value, with how many times are you going to do it. So 200 meals means you have to multiply by 200. Okay, now pause the video and really think about these 2 questions, and then we'll go over the answers. Okay, so for number 1, we have the same table is given to us as what we have done before. What would expect to the expected value if fewer people ordered chili, and more people ordered stew? What's going to happen? Your expected value, your profit is going to go down. Why? Because if more people get stew, which means the profit in which per serving is going to be less than chili, the more people get stew than chili means that the profit's going to go down because the food that really gets you the most profit is actually going to go down. So your expected will decrease. Suppose a restaurant's profit on an order of stew increased by 5 cents. Okay, so the stew gets 0.39 and the order of chili is decreased by 0.05, which means this is going to be 0.68. How will these changes affect the expected profit per meal? Okay, so for the original profit, it was going to be 0.6203. This is your original profit. Now, just because we have changed these values, what's going to happen to your overall expected value and outcomes? Well, let's see. 0.39 times 0.12. That is your stew. Chili is 0.68 times 0.36, which is this one. So we're going to find those two out. So 0.39 times 0.12, which is 0.0468, 0.68 times 0.36, which is 0.2448. Well, since these two are not going to change at all, it's going to be the same thing as this, 0.0287 plus 0.288, which will give you 0.3167. Okay, that will be the same for these guys. So once we add all of these guys up, 0.04468, 0.2448, you're gonna 0.2448, you're gonna end up with, let's see, 0.0468 plus 0.2448. You're going to end up with the expected outcome of 0.6083 as your new expected value. Okay, well, we'll just find out the expected value here. Well, what do we say then? Because here we decrease the value of chili in which more people have sought out for, overall your profit is going to go down, not by a lot, it's only about 2 cents, but it's going to go down. So how would these changes affect the expected value? It's going to decrease. So find out the expected value as you would and just compare them, and that's going to be it. Okay, so you're going to get similar questions like these for today's homework, and that's going to be it. Thank you. Have a good day.